Hello, guys. So, welcome back. And in today's video, we'll be talking about the preparation of colloidal solution by chemical method. If I remind you what we have studied in our previous videos, we have studied about the Bradig's arc method, which is one of the ways to prepare colloidal solution, and it only works for leophobic because leophobics are the colloids that need to artificial processes artificial processes to make colloidal solution, and leophilic are easy to prepare because it can be shaken into a colloidal solution. So let's get to the main point. If we again try to remind you what a colloidal solution is, a colloidal sol is formed when particles of size roughly 1 to 1000 nanometer are produced inside the reaction medium itself by a chemical reaction. So the core idea is that what happens is, in the chemical method, due to the chemical reaction, if I show a bit of flowchart to you, due to the chemical reaction, what happens is that it creates insoluble particles, and these insoluble particles are later on created as colloidal solution. So I think you have got a it is a very basic idea. Let's get deep into it. uh, we're going to basically study four types of chemical method, and the first type is double decomposition, second one is reduction, and third one is oxidation, and the fourth one is hydrolysis. I think we're pretty familiar to these terms. I hope you're familiar to these terms. If you're not, I think there's nothing to worry. I'll be talking about them briefly. So, first one here is by double decomposition. It is mostly common for sulfides. The basic idea is that two insoluble compounds react and they create two soluble compounds. These are soluble compounds. These two soluble compounds mix, and by a chemical reaction they create an insoluble compound, which later on appears as a colloidal sol instead of a precipitate. So you can see I have given the reaction here. I hope it's easy to understand the reaction. You can see what's happening here. The two soluble compounds are reacting and they're creating a colloidal solution here, which is arsenic sulfide. The key line here is that in double decomposition, two aqueous solutions react to form an insoluble substance, which in our case is arsenic sulfide, and it is found in colloidal form. That's how you get a colloidal solution. So I hope it's clear. And in the second chemical method, it is done by reduction. It is very important. It is only done for gold, platinum type, silver, these types of metal. The basic idea for this reaction is that metal ions are reduced to metal atoms, which then aggregate into colloidal particles. If you see, the example here is that the if I show you the reduction, it is plus 3 here and it creates 0. If I show a different color to the charges, you can see that from this process it it has gained 3 electrons. So it is a reduction process. It has gained 3 electrons rather, plus 3 electrons, and that is why it is known as reduction. And we can see another reduction here, which also have the same thing, same mechanism. Let me delete it. I hope you understood what I meant by it. And what happens is that the gold ion here receives three electron and creates a gold atom which has no charge, which is neutral, and by this reduction process we get a colloidal solution which is known as gold sol. We have talked in our previous lectures that sol is what we name colloidal solution. It is shortly known as sol. The main line here is that the reduction of metal ions produces metal colloidal solution. And after that, here the reduction is done by SnCl2, and here the reduction is done by formaldehyde, which you know that from organic chemistry we know that formaldehyde works as a reducing agent. So I hope you understood. And the third one is by oxidation. I think by oxidation we only create sulfur. So a substance is oxidized, producing elemental sulfur in colloidal form. And the example is that if we react bromine to hydrogen sulfide, we get a sulfur sol. And we react sulfur dioxide to hydrogen sulfide, then we also get the same colloidal sol. That's how you get colloidal solution by oxidation. And if you ask how it is oxidized, you can see the sulfur charge here is it is -2, and here is 0. So from this process the sulfur has gained true the sulfur has lost 2 electrons. Oh, it's disturbing a little. From this process, the sulfur has lost 2 electrons, and when in a process, a atom loses electron or a charged thing loses electron, we know it as oxidation, and by this oxidation process, we get colloidal solution. And the fourth step, coming to the fourth method, it is hydrolysis. We get metal hydroxide as a colloidal solution from this process. Hydrolysis is a reaction where a weak base and a strong acid undergo hydrolysis to form metal hydroxide salts. This is a very weak base, and this is uh, here the hydrolysis is a reaction where the water reacts with a component, and in our case ferric chloride reacts with water and ferric hydroxide is formed, which is insoluble, and it appears as a colloidal solution. And not only ferrous, we can do it also for aluminium and chromium as well. So this was our part. Today's lecture is very short, and it's a lot of pressure in my university, so I'm not being really able to focus on this, but I'm trying. I'll be trying to give at least 1 or 2 videos every week. If you ask me why I'm doing these videos, I think personally what I would say is that, well, I'm very passionate about science. I love to understand things, so I thought, why not share my understanding? So that's why. That's basically the reason. And at the end of the lecture, if I have to say something, is that what I would say that you can take notes of these things, or you can also use ChatGPT from my notes to be able to understand them in a better way. I have tried to show you in a very easy way. What I try to do is I try to give you the basic ideas. So if you don't have a really strong basic in this kind of subjects, you've studied them before, or even if you haven't studied, your basic is very strong, your idea about chemistry is very strong, then I hope you'd find it very easy. So that is it. That's it for today. We'll hope to see you in the next lecture. Till then, bye bye.